Hi Del, how are you doing today? So last session we finished off talking about the unit circle and you told me that you were comfortable with the degrees and the radians, but you weren't sure where all the coordinates on that figure came from. So we're going to take another look at this figure and we're going to talk about all of these coordinates around the outside, starting with the 45-degree angle today. So hopefully you remember when we talked about the 45-45-90 triangle, one of the special right triangles. If you remember that, it'll be very helpful in today's discussion. So I'm going to draw a triangle on the unit circle, dropping a vertical line straight down from where the 45-degree angle hits the outside of the circle, and we're going to create a 45-45-90 triangle. That's also what we call the isosceles right triangle, right? The legs are the same, and then we have the hypotenuse. I think you may remember last session I told you that on the unit circle the radius is 1, and so everywhere on that circle that we draw a triangle, it has a hypotenuse of 1. But let's look at how that information helps us to figure out those coordinates. So we set up the triangle, and I'm going to label the legs as x and x, and the hypotenuse as c, and put it into Pythagorean theorem, x squared plus x squared equals c squared. We're going to solve that for c in terms of x. So we add the x's together and get 2x squared. We take the square root of both sides, and we get x root 2. So does this look familiar down here, the special right triangle, 45-45-90, x, x, and x root 2? Good, good. So that's going to help us get where we want to go. We're going to set x root 2 up equal to 1, right? Because as I said, the hypotenuse is equal to 1, so x root 2 is equal to 1. We're going to divide both sides by root 2 to get x by itself, and we have to rationalize that denominator, get rid of that radical in the denominator. So we multiply by root 2 over root 2, and that ends up leaving us with x root 2 over 2. So on the unit circle, when our hypotenuse is 1, our sides are x root 2 and x root 2. If we take that triangle and impose it on the unit circle, we can see that that means that the length x from here to here of this leg and the length y from here to here of this leg is root 2 over 2. That's where these coordinates come from. And every other triangle that is a 45-45-90 triangle has those same lengths for the legs, but because they're in the different quadrants, we have different x's and y's that are positive or negative, right? Down here in the third quadrant, they're both going to be negative. And so we go around those many degrees, and we can now figure out what the x and y are to help us find the sine and the cosine for those various angles. We can do the exact same thing with the 30-60-90 triangle. So we proved the 30-60-90 triangle a while ago using starting with the equilateral triangle, 60-60-60, right, all sides 2x, to find that we had 2x, x, and x root 3. And if we set 2x equal to 1, we can then find these other sides to find out that they are 1/2 and root 3 over 2, and that's where these other coordinates come from. So hopefully you feel more comfortable with all of the coordinates on the unit circle, and if you have any questions, please let me know.